All right, good. We're ready to start.
All right, cool. Start from the top.
All right, so given an array that is sorted in ascending order, containing unique integer elements, write a function that receives the sorted array as input and creates a valid binary tree search with minimal height. For example, given an array 1, 2, 3, 4, 5, 6, 7, your function should return a binary tree with the form 4, 2, 6, and then 1, 3, 5, 7. Note that when we say binary search tree, in this case, we're just talking about a tree that exhibits the expected form of a binary search tree. The tree in this case won't have an insert method that does the work of receiving a value and then inserting it in a valid spot in the binary search tree. So your function should place the values in valid spots that adhere to the rule of binary search trees that I've not heard of. While also see,
okay, my bad.
yeah, if you can kind of give me a rundown of what it's asking.
So essentially, it wants you to, I guess, in the middle of the array, you split the array like at the middle value. I guess if you sort it in the right order, you get the most middle value, and then if a number is less than that number, it goes to the left. It goes to like before. If the number is greater than that number, it goes to the right. And then I guess you go down into those two numbers, and then you do the same with the next set of numbers in the array. So then you do.
So what is this binary tree node that it gave me here? What is this saying?
Here's a binary tree node class that you can use to instruct a binary search tree.
Okay.
So
based off what you're telling me, I need to take let's just create an array here real quick, something to use real quick.
Yeah,
well, I guess it's taking an assorted array, so I don't need to do that. So const. Well, we already have a sorted array. So I'm trying to think what I need to do. Do I need to I need to split, but I'm not sure exactly how to split like an array in half. So I could count the number of items in that array and then multiply that by half and use that number to, let's see here. I'm not really sure where to start with this, Chris, honestly.
Yeah, I'm trying to look at the solution and understand it, so I could try to help you get through it a bit easier.
So from what I did read on it, it talked about creating helper function. Let me create an array real quick. So we'll set const sort array equal to, let's just do like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We'll do that.
Okay, your solution is not that long actually. It's just that they have functions to help me test if you actually create a binary search tree.
Okay.
Now that I know that, I could actually understand the actual solution.
So I need to create. So do I need to create any helper functions?
Yes, they do that here. But it's just they just call it immediately inside the create inside the minimal binary search tree function. So you could create a helper function.
So they do like return minimal BST
helper. Yeah.
Helper. Okay.
And then
they pass in your array, right?
Yeah, they pass in your array, and they pass in 2 other values.
So it'd probably be So you say two other values. Okay. So sorted array. But I need to know what the helper function is accepting before I can.
What it's gonna do, right? So it's gonna be recursion again.
Awesome.
So yeah. So they call this function multiple times inside that function. So since you're trying to kind of split up an array to have like the trying to like go from like the sides in or like from the insides out, you kind of you need to know you need to pass in where to start and where to end on your thing. So you should pass, since you're passing in the array initially, you should pass in 0 because that's the beginning. And then you should pass in the length -1 since you want like the last item.
So the last item, so it'd be, I can think sorted array minus, what was it? I think, oh yeah, -1. No, dot length. I don't know why I did minus dot length.
Yeah, you did.
-1. Okay, that gets us started. So now I need to create, I guess, the helper that I need to create that minimal tree helper.
Yep.
I guess that'll be another function. We'll call it, I guess I gotta call it B. So it's going to take in 3 values, right? So it's taking in sorted array 0. So I need to pass in like parameters, but I don't want to call them parameters.
So the first one's an array. So we should probably just, and then that first number. So what is that first number technically?
The starting spot. So the left, I guess you would call it. Or right?
Left. Yeah, left. Yeah, you're right. Left. Yeah.
Left, and I guess the other one would be a right. And then what I wanted to do is add those two. So if I want to split it in half, I'd have to divide it. Can you tell me how much time I have left? Are you not?
How much time do we give?
10 or 15, I believe.
Okay, you have 3 minutes left, actually.
So I want to create a constant and name it middle, I guess, because I need to split the two. So I need to add the left and the right. So if I'm going to add them and then divide them by 2 to make it half, right? So
yep.
I would do right plus left and then divide that by 2. Does that look right to you?
Yep. That's good to me.
And then so now I have the half. Now what do I do with it? Is there any info you can give me that would go?
So now you need to make use of that class at the bottom.
The binary tree node?
Yep. So you make a node.
So const. So you're saying const binary tree is like equal to.
Well,
so I'm recreating this binary search tree, so I'm not like actually referencing it, right?
Yeah, well, right there you're supposed to make a node.
A node, so const node.
Yeah.
And then, am I referencing or creating a new binary search tree?
You're creating a new one, so you're creating the nodes to make the tree.
Class, no. Forget how you do this when we did classes.
It's new.
New, new, and then I'm creating a new binary tree node. And this I need to sort middle.
Yep.
Oh yeah, so I'd actually do, I'm gonna pass in sorted array. Oh, and I need to set it to index of, or no, I'm passing the actual middle that I created. I'm kind of lost. Let me see where I'm at right now. So what I've done so far. So I've sorted. So I've created a new tree from this here, this dot left and this dot right. So that's a constructor class. Created a new constructor class, sorted array middle.
Oh, you named it array, not sorted array.
I thought I named it. Oh, up here I named it that. I was thinking of this.
Yeah.
Okay, so where's this coming from? Replit.
Oh, line 17. Yeah. You started with before M. Yeah. You don't need that. Yep.
So that means I don't need this.
Yep.
Okay. So now that I have the middle, pass the array through. And I've passed that through to this middle. What do I need to do next with it?
So you made your first node. You made the first node, right, of the tree.
Right.
And that node has a left and right value. And that needs to be the middle of, holy shit, I'm starting to understand this problem. Okay, now that I'm looking at this, so that left and right value need to be the middle of the middle part of the next side of the middle. All right, so you need to assign left and right to that node, right?
So I need to assign a left and a right. Okay, let's go ahead and do
so
that.
Then to assign a left and a right, you basically, this is where the recursion comes back in, where you pass in that same helper function you just made.
Okay, so the minimal helper, and it takes in 3, so I'm going to pass in. I'll pass in sorted array from up here, right?
Yeah, so you just pass in array because you have it's called array inside that function.
Oh, that's
and now you need to pass in a new middle and a new left and a new right.
A new left and a new right.
Yeah. So since that one's right, the beginning should be
middle. It should be middle, and then do a right. Correct.
Yes.
And then this is pretty much the same thing. And we'll do array. We'll pass in a middle and then a left, I believe.
So then that's making a node that has a left and right value, a node that has a value, the middle value, right? That has a left and a right value. And then those are each nodes. So those nodes have a value and a left and a right value.
So this is it then. I'm going to truth to see if it works. Do we have a console log that I can use?
We have a, here. I'll pass it into Slack.
Yep, I'll get it from there.
Time, so this is the whole thing to test it. I thought it was
Whoa. All right. So.
Oh wait, the whole thing.
The whole thing.
Yeah. That whole part is so I'll put it up below the binary tree node. That whole thing is just to test it.
Whoa. So I need to put this all below this?
Yeah,
That's wow. That's a lot, man.
yeah, and I would delete the top part. The console logs that you put.
Did I put console logs? Oh yeah,
Yeah.
these.
You have an error below somewhere, I think. Oh, because it's not commented yet.
Let's just get rid of this here. Okay. So that should be ready to.
Yep.
Let me pull this here. Where's the console log at?
Right below. Yeah.
All right, different.
Um.
So duplicate declaration.
Yeah, because you made sorted way up top.
So I did this here. Yeah, that's right.
Yeah. No. Oh yeah, you already made one. Yeah.
Well, let me get rid of mine, and we'll use the one that they used.
Yep.
That way the tests are accurate. We'll run, and then create minimalist is not defined, or create minimal BST. Oh, is it the test is one?
Oh yeah, that's what, yeah. So just
See,
use that.
I named it. Yeah, I can just use what you called it. So instead of minimalist, I need to use create. Well,
Quick thing. To highlight minimal BST helper, like highlight it.
yeah.
Oh wait, never mind. I don't think you could do it on Red Bullet. I was gonna say Control D, and it highlights all the same.
Control D. I just did that and it didn't. So
Yeah, it didn't do it.
like getting rid of it.
Yeah, I would. Yeah, I just need to do it the hard way.
Create. Did I use it anywhere else? Nope. All right, let's try it. Create minimalist is not defined.
Oh yeah, because you need to do the line 13. Needs to be function create minimal BST.
13 here.
Yeah, create minimal. Yeah.
This should work. Well, I meant like it should not run into that area anymore. So it's still doing it.
Create minimal BST helper is not defined. Create minimal. Oh, because line 17.
Yeah, you're right.
All lowercase c.
Same thing.
Line
Create.
17. Yeah.
Yeah, didn't I just change? Oh, lowercase c.
Yeah.
Okay. More debugging and just syntax than was the whole project. Okay. So maximum call stack size exceeded.
Yes.
That's not what we want.
Yeah. So I guess since we're past the time, I could just give you the solution. You're basically right. You just need to round the line 18.
This here. Oh, I need to round this.
Yeah. So it's like it's mathed out round, and then you have that in there. Oh, mathed out floor. Mathed out floor. That's what they use.
You pass this into the whole thing.
Yeah. And then on the node left and node right, for the right, they do mid -1.
Maybe get that there. And then here they do are they in the right order?
Yeah, then the right order. So they do middle +1 for right.
And then -1 for the left. Yeah, that makes sense. Middle -1. And let's see if this runs.
New binary search tree. Return node. Oh, okay. You need to return a null value so you can stop the recursion. So at the top, the first line in the function, so between line 17 and 18.
Yeah.
You need to add a check. So if right is less than left, return null. Max dot for that right plus. Okay. Okay. Const node dot left. Do you have an error there?
All right. So the order did matter here. So it had to be left, then middle, or middle plus one and right here.
Yeah.
Okay.
So I
So
thought you had that. What you had before?
I had array, right, and then middle plus one.
Oh, okay.
Okay. So it returns. What should these return? Does it have? Should return true.
Yep. Should return
3.
true, 3, true, 5. Yep.
Awesome. So I got it after a lot of help and pretty much me and Walker. All right, I'm gonna
So I
stop
kind of get it
recording.
now. Yeah. I don't know.